Guys, today we're going to talk about solving a system of linear equations using graphing.
And this is like the heart of this class. So pay attention. Okay.
All right, so first of all, let's talk about what is a system of linear equations. You have a blank on your paper. You're going to write this in the box. A system of equations is a collection of two or more equations with the same set of unknown values.
There you go.
So write that down. If you need to pause us, go for it.
Yep.
Okay, and then what we're talking about here is trying to find the solution to that. So the solution,
It's another word for answer.
oh yeah, it's just what's the answer to this? So the solution is an x and a y value, which is an ordered pair that satisfies both equations. Basically, it means that
It makes both equations true.
it makes both. If I plugged in the x and the y to both equations, I would get the same answer for both equations.
Right.
Now, when we're talking about a solution on graphs, if we were going to graph these, it's where the two lines intersect.
So it's written as an ordered pair
Mm-hmm.
or where the two lines intersect.
Correct. So let's look at how this works. So here we have two equations, and I've given you 3 steps.
Okay?
Step number 1 says graph each equation on the same coordinate plane. So you want to use different colors
I will.
or highlighters?
Yep. So I'll do green
Okay.
and then I need another highlighter.
The yellow one?
Yeah, I was hoping to get the same color over here. We're good.
Okay. So we're going to graph that first equation, and it is in slope-intercept form.
That's
And
great.
so-
we know all about this.
Mm-hmm.
So I start with my -3.
-3 on my y-axis. Put a dot. Oh, I love the green.
Yep.
And then our slope is -2.
Okay, so that's the same thing as -2/1, which we
I
talked
don't
about
think
a
I
lot.
can see it on the white.
-2/1.
Mm-hmm.
Oh, come on.
And then, okay,
Negative
-2
2
over
over
1.
Or the opposite of that would be,
Up 2 over to the left 1.
yep, which we've talked about a lot. And then you just go as much as you can. Now,
Yeah.
from here, grab our straight edge.
Mm-hmm.
Okay, connect your dots.
All the way across that graph. And you guys know that.
Yep,
Actually, you guys have done
lots.
Yeah.
Arrows on the end.
Okay. So our graph, why don't we, let's highlight that with green.
Okay.
Is that cool?
Yeah.
Okay. So this line is the top equation.
Okay.
Our second equation, we're going to do the same darn thing. So
On this same one, correct?
on the same
Okay.
graph. So we're going to put our y-intercept at 5. Awesome. And then our slope is 2.
So +2.
So we're
over
going to
1.
go up 2 over 1. And
Uh-oh,
shoot,
now
I'm
we're
already
going.
off the graph. So now I can reverse it.
Go back to my y-intercept.
Down 2 over 1.
Left 1, down 2, left 1, down 2, left. It crossed. Is that okay, you think?
Yeah, it's totally okay because we're
Oh,
looking
perfect.
for where it intersects.
Okay, so I did my points as far as I could go,
Mm-hmm.
grab my straight edge, connect my dots.
Mm-hmm.
Am I missing anything?
Arrows.
Oh yeah, arrows. Okay,
Okay, now, because the arrows indicate that those values would go on forever. So now, to find the solution, I look, it says, okay, step 2, find the point where the two lines intersect.
Okay.
So
So that means I can just follow these guys. So I follow. Oh, right here.
Mm-hmm. And then write that point as an ordered pair.
Okay,
So that point,
so that's step 3 is to write it.
mm-hmm. So the solution is -2, 1.
So I write that as an ordered pair.
Mm-hmm.
-2, 1. And so this is where it kind of starts to get confusing, I think, because you told me to go left and then up for an ordered pair, but yet for slope it was the opposite of that.
Right. So
So
again,
guys, just make sure you're doing X, because we know an ordered pair always goes X and then Y.
Mhm.
So you do your X-axis first and then your Y. As for slope, we know it's rise over run.
Yeah.
Write that down if you get confused between the two.
now you can, and we're not going to check every single one, but you can check.
And this is the coolest thing.
So again, we said that this ordered pair would satisfy both equations. So we're going to plug it in for x and y in the first equation. So we're going to have y equals 2x minus 3, and we're going to put in -2 and 1. So it's going to say 1 equals -2 times -2 minus 3. Now we solve this. 1 equals
Four.
Okay, positive 4
Mhm.
minus 3, 1 equals 1.
So it works for the first equation.
Yes, perfect.
Okay.
We got the same thing. So let's check the second
So now
equation.
the yellow one.
So y equals 2x plus 5.
Okay.
So this will say 1 equals 2 times negative 2 plus 5. 1 equals, and that's a 2 times negative 2 is negative 4
Negative 4.
plus 5. 1 equals negative 4 plus 5 is 1. And it worked again. So we've satisfied both equations with the same ordered pair, so that is the solution to that system.
And so like we said, you don't have to check it every single time, but you have that option
To
every single time.
To see if your work was right.
Mhm.
Okay, here's another example. Okay, so the first equation says y equals 4x. What's the y-intercept?
Well, nothing's written, so I would think it'd be 0.
You are correct.
Perfect, because a 1 would be listed.
Yeah, if it was 1, it would be there. But
Mhm.
so if there's no y-intercept listed, that means it is at 0.
So you can either write plus 0 or leave it blank and just know that.
Okay, so put it there at 0, and then my slope is 4 over 1.
So start at the y-intercept, up 4, write 1. Do it again if I can. Over.
Okay, and then now I'm going to go the opposite way to fill in the
Okay.
rest of the graph.
So back to your y-intercept. 1, 2, 3, 4, left 1. Down 1, 2, 3, 4, left 1. Connect it with a straight edge. Okay.
Awesome.
And guys, if you haven't been using a straight edge to date, this is where it gets really important that you do so.
Really important, because
Yep.
if you're just willy-nilly with your pencil, you're not going to get the right intersection.
Yep.
All right, so this one says y equals x plus 3. So my y-intercept's at 3,
Mhm.
but then there's
Oh, it just
nothing
says
in...
X.
Yeah, well, I know, and I know we all know that there's an invisible 1 in front of that x.
So visible 1 on top and bottom. Okay.
So up 1 over 1.
So what happens, I've already found my intersection. Do you think I still need to plot all
You
this?
still need to plot it.
Okay, so back to my y-intercept, down and left. Just continue this as much as you can. Guys, this is kind of fun, actually.
What's really great about seeing that point of intersection right before, before you're even connecting the dots, or you put 3 dots on, is you've probably done it right.
That's true.
So we're going to find where that point of intersection is. It looks like it is right there. Yep.
Okay.
So that is my x is
So
1,
X first, 1,
and then 4.
1, 2, 3, 4.
So my solution is 1, 4.
So that is the answer that we're going to read aloud. Okay?
There you go.
So
And
then I
again,
can check it.
Mhm.
So here, to check this one, you would say 4 equals 4 times 1. Well,
4 is 4.
there you go.
Yay for us.
Next one would be 4 equals 1
Plus 3.
Well, that one was easy.
Awesome.
Done.
Okay. Okay. Another example.
There you go.
Now, one thing that we need to tell you is that there can be one solution, there can be many solutions, or there can be no solution. We've shown you examples of one solution. I think this is also going
And
to be...
that's where this crosses over. There's one spot where it crosses over. Okay.
So let's look at this one and see what happens. I think this is a one solution, but I'm not sure. All right, so we have y equals x minus 1. So down to negative 1 for my
Okay.
y-intercept.
So I plot the first order pair first, or first line, and my slope is up and over, because we know that x has a coefficient of 1 and a denominator of 1. Go back to the y-intercept, down and left.
Love it. Now we're going to use our straight edge, connect the dots, put arrows on the end.
Okay, done with that one.
Now we'll
Next.
do 2x minus 2, so down to negative 2,
Okay,
and it's up 2 over 1. Again, I see my point of intersection right there,
so
but
we
I'm
know we
still
haven't made a
going.
mistake. 2 over 1. Okay,
Use my straight edge, connect the dots.
you see our point of intersection?
I do. I see it right there on the x-axis. So,
it is on the line. Okay,
so my solution to this one is going to be 1
so I move over first,
and then 0.
because we didn't go up.
We did not go up any direction. Okay.
And then
cool.
you guys can check that if you want.
Okay. So now this one. 2x plus 1.
Oh,
Where'd
man,
the
that
tools
seems
go?
right. I don't know.
That's weird.
Okay.
You want me to go get them on?
Probably. For this one, yeah.
Okay.
Okay, so here we are. Sorry about that. We're still going to plot this first one. So we start with our y-intercept at 1. So we go to the origin, up 1, plot our y-intercept.
Mhm.
Our slope is 2. We know there's a hidden 1 underneath. Up 2, right 1, up 2, right 1, and so on. Out of spots, go back to your y-intercept. Down 2, left 1, down 2, left, down 2, left, down 2, left.
Connect the dots.
Let me fix that guy.
There we go.
Then we put arrows on the end. So we plotted the first one.
Okay, let's plot that second one, see what happens.
Okay.
-4.
Origin, down 4. Our
And
slope
then
is
up 2 over 1.
2 over 1. I think that's the same slope.
It is the same slope. We had the same slope as the last time.
Oh, that's, yeah. Up 2, right. And go back to your origin. Down 2, left 1, down 2, left 1.
Okay, so did I do something wrong because we didn't connect it? We haven't had a point of intersection.
Well, I mean, I remember you saying that we might not.
We didn't do anything wrong, guys. And that's what's awesome. So there is no point of intersection on these.
Right.
So our solution is no solution.
No solution.
And you would write, you're not gonna write no, you're gonna write no solution. Now, here's how we know that it is no solution. These lines are parallel.
Right.
So would you please write on your paper, parallel lines never cross.
Okay.
They have the same slope.
Okay.
And that's okay. It's okay for us to have a no solution. So when you see lines that have the same slope, but a different y-intercept, they're never gonna cross.
Right. Just like this at all times.
Mm-hmm.
There you go.
And that's okay. Okay, so there's no solution to that system. Now, let's look at this one.
Okay.
So let's look at number 1. The first one is 6 over 2x plus 1.
Okay.
So,
Always start here.
so
Up 1.
mm-hmm.
What do I do with a fraction as my slope?
Well, you can just do that,
Oh.
or you could simplify it if you wanted to.
Okay.
I know that 6 over 2 is 3.
Okay.
So that'd be 3 over 1. So up 3 over 1.
Okay, so I can do up 1, 2, 3 over 1.
Mm-hmm.
1,
1,
2,
2,
3
3.
over 1. Or I can go down 6. 1, 2, 3, 4, 5, 6.
Over
Left 2. 1, 2.
Yeah, it's the same
Same
thing.
thing. So if I would have gone down 1, 2, 3 over 1,
It's right
still
there
in
in
the
the
path. Yep.
Okay, and then we're going to connect our dots. Cool. Now, we're going to do the second line. And it says y equals 3x plus 1. So I'm going to put my y-intercept at 1, and my slope is 3, up 3 over 1. Well, it looks like...
Oh, wait a minute. Are you
I'm-
sure?
Yeah, it says that. So I'm making the exact same line, which is okay.
Okay.
Because I told you guys at the beginning, there was going to be some times where we have many solutions. Now, this is the exact same line. Those arrows tell me that it goes on forever and ever.
Mhm.
So how many solutions are there?
Well, I see a solution here and 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 here. And
So everywhere on, those lines are intersecting everywhere because they're the
Everywhere.
same darn line. So we would write infinitely many solutions. Not just many solutions, infinitely many, because those lines go on forever. So till infinity, to infinity and beyond.
Yep. Buzz Lightyear will meet you there.
So infinitely many solutions, same line, infinitely many.
Okay. So same line equals infinitely.
Mm-hmm.
I-T-E-L-Y.
And you'll know if it's going to be the same line if you have the same equation.
Got it.
Cool. So there you have it. Guys, we will practice this tomorrow, and we will see you.
On the flip side.
Bye-bye.